Quick exit note. When the meetup ends, we have a beautiful lobby downstairs. If you don't mind going downstairs and socializing, that would help me out a lot, because I can clean up the room and kind of get everybody in the room.
Are we mirrored? Okay. All right, let me just get screen recording going and we'll be good to go.
I'm going to pass these around. Please just take one. I counted them.
Okay. Ready?
Yeah.
All right. Hi, everybody.
Hi.
Oh, come on. Hi, everybody. That's better. My name's Dave. Thank you all for coming today. I'm an Android developer here in the Denver area. I actually live in South Denver in the Highlands Ranch area. So nobody came from the South, it sounds like, so I think I'm on my own in that one. I work for a company called New Circle. We're a training organization. We focus mostly on open source, and Android is of course a part of that. So my responsibility there is to handle the Android program, Android courseware, trainings, that sort of thing. So if you guys are interested in Android training, or if you want to do some training for your organization, feel free to connect with me after that. Google Developer Expert for Android just recently, and today we are going to talk about beacons. So this talk has been renamed at least 3 times in the past 2 weeks, thanks to Google. But that's a good thing, because we've got some cool new stuff to talk about that really has only been on the shelf for a week or less. So we've got some really cool stuff we're going to talk about today. We're going to talk about 3 primary areas. We're going to talk about Google's beacons and a beacon format that you may or may not have heard of called the Eddystone. We're going to look at Google's beacon APIs, which is something they just recently released. And then we're going to talk about something called the physical web. If you've never heard of that before, don't worry. We're going to dive into it a little bit deeper. So let's get started. Who can tell me here what a beacon is? Just shout it out. Bluetooth device. Okay, Bluetooth device. What else?
Low energy.
Okay, Bluetooth low energy or Bluetooth smart. Yep, yep.
It broadcasts something constantly.
It's broadcasting data. That's true. Absolutely. Anything else?
Helps location-aware interactions.
Okay, oftentimes used in proximity. Very much true. Cool. So a couple other things in addition to that, in addition to the fact that they broadcast, which you may or may not know is that broadcaster is a Bluetooth term. And what it actually means is that it's a device that transmits or advertises data, but you are unable to connect to it. That's what's a definition of a broadcaster in Bluetooth terms. And that is what most people think of when they think of a beacon. It is a Bluetooth device that is broadcasting stuff out into the world, and we call that advertising. And it's doing that on some regular schedule, and even if you wanted to, you could not search out and connect to this device. Its only job is to broadcast whatever information it has for anybody who's listening. Now, one of the other important pieces of information to know about broadcaster devices in Bluetooth LE is that the amount of data they can send is extremely small. 31 bytes is the amount of information that can fit into an advertising packet that one of these beacon devices is transmitting out into the world. Okay? And that becomes pretty important as we start looking at different formats. You realize that they really have to try and cram all they possibly can into this space or come up with other solutions. Okay? And it turns out there's a little bit of both. So, very good. Who's familiar with iBeacon? Who's heard that term before? Somebody tell me quickly, what is iBeacon?
Apple's beacon technology.
Apple's beacon technology, right? Apple was the first to the punch in really kind of pushing this standard forward with what they called iBeacon. iBeacon was a technology that was introduced originally in iOS 7. It was originally intended to be broadcast by iOS devices, not by other embedded devices. The idea was you would turn your iPhone or your iPad into an iBeacon, and then other users could find the information that was broadcasting and be able to do some basic functionality associated with that. So I just want to quickly give you an overview of what iBeacon looks like from a standard perspective. To be honest, I can't actually tell you everything because it's actually protected under Apple's MFI program. So there's some stuff omitted here because if I say everything, I'm in trouble. But the important stuff is on the slide here. So that 31 bytes that I just showed you from an iBeacon device looks essentially like this diagram that I've got listed here. Okay? Now there are a couple pieces of information in here that are interesting. The iBeacon device broadcasts what's called a unique identifier. And that is intended to be unique for a specific application. So every application or every deployment of iBeacons out in the world is intended to have a unique identifier for that specific app. And all the beacons associated with that application all share the same UUID. Then they have these additional values called major and minor that are intended to discern the individual beacons one from the other. Okay? So if I were, say, Dunkin' Donuts, and I wanted to put an iBeacon in every single one of my stores, and all of those would be detectable by our native application on the iOS or Android device, then every single one of those beacons would have the same unique identifier. But they would each have a discrete, either major or minor value that allows the application to determine which one is in this location versus this location, and so on and so forth. What those values really mean is completely up to the application. They can be anything you want. They're just numbers. They're just two integer values, two 16-bit integer values. And your application can use those in concert to use whatever schema you want to identify those individual beacons. Okay? The only other thing to know from a Bluetooth perspective about iBeacon is that that blob of data that's in that advertisement is something that's referred to as manufacturer-specific data. Okay? Actually, this little byte right here, this FF, is what describes that. Basically, what it means is that from a Bluetooth specifications perspective, everything that's in this array has no meaning. There's no Bluetooth standard associated with iBeacon. Apple is basically saying, we're going to use this whole payload for stuff that only is interesting to us. And nobody else cares or has any interest about what's going on here. Okay? Just keep that in the back of your mind. A couple other additional things about iBeacon. This is going to become interesting when I talk about some other stuff later, but the iBeacon standard defines that every beacon device has to transmit its advertisement 10 times every second. So part of the spec is that it has a 100 millisecond transmit interval. Okay? Now, that may not sound as interesting right now, but just keep that in the back of your mind as well when we start talking about some of the other formats. Okay? The primary use case for iBeacons was private application deployment. Okay? The idea was I had a native app that I wanted to integrate this type of location type service, micro-location type service in, where as a user would walk into, say, my retail facility, or if I had a large facility, maybe as they walked around into different locations, I could use these detected by my mobile app scoped to that specific user identifier. So it pretty much required that when I deployed the beacons, I had to have an app associated with that to be able to handle all that. And if someone else had a different beacon deployment, they had to have a special app for that. So there's an app on your phone for every single one of these things. Okay? Also important to remember. Google, on the other hand, has come out recently with their own version of this specification. Now, they actually had a previous version called UriBeacon that has evolved into what we now call Eddystone. So if you haven't seen it before, up in the top corner, that is the Eddystone logo. Okay? So if you ever see that logo anywhere, that's what it's for. Google has created their own beacon format to satisfy this exact same use case. They call it the Eddystone UID. Okay, so this packet that I've got listed here is, again, this is that same 31 byte frame, but now this is what Google does with it instead of what Apple has been doing with it. Okay, now just a couple minor differences here. One is that Google uses Bluetooth standard packet frames. So this service UUID and this service data block, those are defined by the Bluetooth SIG. And the way that they're structured is recognized by Bluetooth. It's not a real big deal, but it's just something to realize that Google is using standard Bluetooth frames where they can, instead of just saying, it's all manufacturer specific, we'll figure it out. Okay? Not a real big deal, other than it's just interesting to know. But a couple things that you'll find in this packet is we have what we call the frame identifier, which in this case is 00. Just remember that for now, we'll come back to it. We have that same identifier information, but described in a slightly different way. So in an Eddystone, they describe something called a namespace ID. It's effectively the same thing as that UUID I just told you before. It's something that should be consistent across all the beacons in a deployment for a specific application. And then we have this thing called an instance ID, that is, again, should be unique per beacon inside of that application deployment. So we have the same basic idea, they're just slightly different sizes in terms of fields. Was there a question?
Just quick, how do you spell Eddystone, E-T?
E-D-D-Y-S-T-O-N-E. Good question.
So it looks like the UUID and namespace ID are different bytes.
They're different sizes, exactly. So in iBeacon, it truly was a UUID, which is a 128-bit, 16-byte value. In Eddystone, that namespace is only 10 bytes, which actually is nice because it means we get a couple extra bytes for declaring the instances. So we actually have more room to be able to differentiate the instance elements, the individual beacons, as opposed to we don't necessarily need all that space just for the application. So not a big deal, but they're definitely different sizes. Now the other piece of information that I skipped over but is in the iBeacon frame as well, and I'll point it out here, is this byte here called the transmit power. Now this is important for beacon ranging. So part of the beacon specification is that not only are we determining when an application or a device comes within range of one of these things, which is important to know, but it may also be interesting to you to figure out which one are you closest to. Okay. Now, just general radio, the way wireless stuff works, when devices like your mobile phone are listening for Bluetooth, Wi-Fi packets, all this stuff coming in over these radios, every single one of those packets has a signal strength associated with it called the Receive Signal Strength Identifier, or RSSI. Okay. That's basically just a calculation of how strong is the signal from what I just picked up from the transmitting radio. Okay. By itself, that information is useless for ranging purposes. It tells us how strong the signal is, but without knowing how strong the signal started out, that math doesn't work out. So anytime you're dealing with any type of wireless technology that has a ranging component, and beacons are typically part of that, we have to make sure that the standard dictates that it transmits along with its advertisement in the Bluetooth case what the power was of the radio when it transmitted this packet. And then the receiver can take what it knows about how strong the signal was when it received it, figure out what the transmit power is, figure out the difference, and then it can have a rough calculation of about how far away it is. Now this is not an exact science. This math is not going to tell you that I am 5 feet, 10 meters, 100 meters away from anything necessarily, especially because going through walls or anything like that is going to change that signal profile. But typically it can give you a close enough approximation to figure out, am I right next to it? Is it maybe on the other side of the room, or is it on the other side of the building? Right? So typically, and you see this with the Apple APIs for iBeacon as well, they put these things in buckets, like near, nearest, far, or just barely detected type thing. So you can use it for that, and so the transmit power will always be in the beacon frame specifically for that reason. But don't necessarily rely on this to get you meter or foot accuracy in most cases. Certainly not in a beacon type environment. You'd have to tune the radios for a more specific application to do that kind of thing. Okay. Now, yes?
Do you mind, is there any way you can change the color that you're highlighting things with? It's pretty hard to see.
Let's see, how does red look?
That'd be fine, I think.
Red or green? You pick.
Oh, red.
Okay. Red it is.
Didn't even see the green one.
All right, we'll use red. So a couple other things. I mentioned before that the iBeacon transmit rate was 10 times a second, right? Well, it turns out that the Eddystone format doesn't actually declare how often you need to transmit, but by convention, partially because this is the way UriBeacon used to work, the typical Eddystone is going to transmit its advertising packets once every second or even every 2 seconds, somewhere in there. So it's about 10 to 15 times slower than iBeacon. Now that becomes really important if your beacon happens to be battery powered, okay? Because the more times you turn on the radio, the faster you're going to kill the battery, okay? Now the thing about using iBeacon is Apple tells you you have to transmit that fast. You have no control over it. So an advantage from a battery powered perspective of using Eddystone, really any other format you declare, but in this case the Eddystone format, is you can transmit less often, which means your batteries can last, let's say 10 times as long, on the same hardware and all that other stuff taken into account. So that's a really good thing. From an Eddystone UID perspective, it's really solving the same problem, just in a different way. Okay, so it's solving the same problem of I want to take a bunch of beacons, I want to deploy them out into the real world, and I want my native application to be able to detect my beacons, right? So it's still one app per deployment, and this guy's got an app, and this guy's got an app, and so on and so forth. Okay, so that hasn't changed. It's the same use case. But What the Eddystone format does is it goes one step further. And they've also defined another packet format called the URL format. Now this, if you're familiar at all with the previous specification of UriBeacon, is really what UriBeacon became. Okay? This is a beacon that advertises a standard format that we all know and love, the URL. Right? It is a well-known, well-understood identifier to a resource that could live anywhere. It could live on your mobile device, it could live out on the open web, right? It doesn't matter. Okay? And this unlocks a totally different use case that we'll talk about a little bit later called the physical web. So the idea behind broadcasting Eddystone URLs is not that I would have a native application scanning for these things, but rather there's one common place on my device, in this, for now we'll just call it a physical web scanner, that can handle any of these URL-based pieces, and they all come into one common scanning application or process on my phone. Okay? So that's a big change. And we'll talk more about what you can do with that and what the purposes of it and all that stuff a little bit later. So, primary differences between the two. Anybody have any questions so far?
Is there a cost for the iBeacon technology to broadcast?
Cost, you mean like financial cost?
Licensing cost?
No. MFI licensing is free. You basically have to go through the process of signing 1,000 NDAs and hire a lawyer, that type of thing. But it doesn't cost anything from that perspective, no. You can license the usage of iBeacon either to create your own beacons, or if you wanted to directly read the format without the iOS APIs, you would need an iBeacon certification for that too. That is free. You just have to go through the process. Good question. Other questions? Okay. All right, so I'm going to dive briefly into each of these formats just to give you a little bit more of what they would actually look like if you were implementing these in the actual beacons themselves. So Eddystone UID, that's that first format that's more of the iBeacon competitor that I mentioned. Basically, the way that they encourage you to generate this information looks something like this. So it turns out that namespace ID, you can pretty much come up with any way you want to make that happen, right? As long as you have some random association of 10 bytes, you're good. But they have some recommended ways for you to do that to help guarantee that your choice of 10 random bytes is going to be unique as opposed to somebody else's, right? So the primary recommended way is basically to take a one-way hash of a domain name that you control. Right? And in this example here, this is what the hash looks like if I do this with newcircle.com. Now that's 20 bytes. So the idea is you take the first 10, hack that off, and that becomes your company's namespace. Now they have a couple other ways that you can do that I don't have examples of. They tell you can generate just a random UUID and then hack out the 10 bytes from that you need. Or if you want to make up your own, go for it. But these are kind of the ways you would typically do this. So you generate what becomes your company or your application's namespace ID. And that's going to be consistent across all your beacons. Mike?
Is there a way that you currently need to register UUIDs, or are those just
No, you don't.
luckily unique because there's so many?
Exactly.
There's
Yeah.
no master.
There's no master registry or anything like that, which is true with iBeacon as well. There's no place that you declare this is my UUID. You just try to make it unique. Okay. So then the idea is, for each individual beacon in your deployment, that packet frame that I showed you before would look something like this, for those of you that can see that far. That first block of the UID is the same for every single beacon, and it's the bytes that I generated up top. Okay? Then the trailing 6 bytes are that instance ID, and they can be anything you want, but you obviously want them to be different for each individual instance. So in this case, I just have them sequential, 1, 2, 3, 4. You could have a bit mask where each one only has 1 bit flag set. Do whatever you want, right? Whatever works for your application, but you want those to be unique, while the remaining bytes, the namespace, would technically be the same for each individual one. Okay? Make sense?
That's within a physical region?
It's to be scoped for your entire application. So like in the Dunkin' Donuts application, all the beacons that Dunkin' deploys to all their stores that talk to this one app would all have the same namespace. If you wanted to sort of subdomain that a little bit, you could. I mean, there's nothing keeping you from coding an app to support 2 different namespaces if you wanted to separate them out that way, and by region, perhaps. There's nothing in the standard saying you can't do that. But the simplest idea is that's sort of one consistent thing for the whole app. Good question. Okay. So let's take a look at some Android code about if we had some of these Eddystone UI beacons out in the world, how would we talk to them? Okay, so the UID beacon, and for instance, this one that I have right here in my hand is an example of one. This is typically a beacon that's designed to be attached to some embedded device transmitting. So more often than not, your interaction with a UID beacon as a developer is going to be scanning for them and reacting to the presence or the proximity of these particular devices. So this sample code is really just going through the process of, at a very basic level, how would you set up a scanner to scan for an Eddystone? Right? This is using the newer Bluetooth LE APIs because they give me lots of fun stuff like filters that make this a lot easier. You could do something similar with the older version. You just have to do a little bit more work after the scans come back. Okay? But basically, the primary data that I would need is I would need to define the UID service, and this is a constant value. This UUID with that FEAA in it, that is the service that every Eddystone, everywhere that you go, is going to broadcast as that UUID in the service packet that I showed you before. That's always going to be the same. So that you can use all the time. The additional piece of information that you're going to want to filter on if you can, meaning that you're running on a version of Android that supports this functionality, is you can add an additional filter for your company's namespace. And this allows you to apply a filter to the framework so that the only beacons you actually see in your application code are the ones that you're interested in, without having to deal with a bunch of scan results and then having to figure out, well, I don't care about that one, throw that one away. Okay, I can push that down into the framework by supplying a filter. And in the case of an Eddystone UID, this is what that filter would look like. The bytes around the packet, those pieces in the front where the transmit power is and the pieces on the end where the instance ID is, that's not important. But this specific piece in the middle, that's my namespace ID. Okay, so you would want that to match whatever we generated in the previous slide. Okay, I realize in this example it doesn't, sorry, but that's what you would want. And then in addition to that, you supply what's called a filter mask. And that's basically just a bit mask. It says, of the filter I just gave you, which bits have to match and which bits can be anything. Right? So you can see that lines up with just the namespace portion. Now it actually lines up with one other piece, which is this first byte here. And that's because that frame type, as I mentioned before, is always 00 for a UID beacon. So you can pretty much guarantee that should be the same. Transmit power could be anything, and then the namespace ID has to be the same too. Okay, with me so far? Awesome. So then if we look at the code to set this up, there's two things that you need to set up for a beacon scan in the Android Lollipop-based BLE APIs. You need any filters you want to apply and the scan settings. So the filters that you will apply simply have two pieces of information in it, and that corresponds to those two chunks I showed you in the ad packet. There's the service UUID element, which just has that service, and the service data element, which we pass the two filter elements into, and then that constructs the filter that we hand down to the framework. This tells the framework, only call me back if the scan result you got matches all this stuff. If not, I don't care. Okay, so this is something I can't do with the BLE APIs in Android 4.3 and 4.4. Okay, so this is a very nice feature of the new stuff. Basically, if I'm using the older APIs, this goes away, and I have to deal with every scan callback and check those two byte arrays manually myself. Is this one correct or not? Okay, it's kind of annoying, but it still works. So you define that filter, and then you have to define the scan settings. Scan settings are just basic things like how often do you want the scan to run. Right? If you're doing this in the foreground, you probably want something like low latency so that it picks up quickly. If you're scanning in the background all the time, there's a low power setting that you would use so that you're not just turning the radio on full blast and wasting everybody's battery. Right? So you would tune this to your actual application depending on what it is you're trying to do. Those two values get popped into the Bluetooth LE scanner. Where am I drawing? There we go. So you get the Frameworks LE scanner, you pass it the filter and the settings, you start scanning, right? And then each of those individual results comes back into the scan callback. And then at that point, you can inspect the beacon frame, figure out which one it is, which instance was this, and do something associated with that. Now, there's no APIs or libraries or anything like that at the moment to help you parse this data out. So you saw that setting the filter was kind of ugly, but it worked. But at least that cleans up what we get back. If we want to get, say, that instance field out of the beacon, we have to do it by hand. Okay, and I don't have, the code is omitted out here on how to do that, but basically I would have to take that raw byte array, take the last 6 bytes of it, and then turn that into a number or however I wanted to parse that information. I would have to do that myself as it stands. Okay. There is a rumor that the new Nearby Messages API that was just announced at the same time as this is going to make this easier for you. Now, the documentation isn't out on this yet. I've seen some code on one slide out there in a video somewhere that tells me that this will get easier, but I can't tell you exactly how. Okay. In the new Nearby APIs that are going to be part of Google Play Services, they're going to allow you to declare what they call a message filter, where you just say, I'm interested in an Eddystone, here's my namespace. And theoretically, the callback that you get is also quite a bit cleaned up in terms of here's which one you got. Right, that sort of thing. So if you're using Google Play Services or you're interested in any of that, that should get better, and I'm assuming that doc's got to come soon, because I mean this has already started pushing out to some devices. So we may see that even in the next week. So this could get easier, but even if it doesn't, here's sort of the basics of how you could do it on your own. Okay? Questions so far?
You said it's being pushed out to some places?
So I've heard, yes.
Wait, is it from Google Play Services?
Yeah.
Oh.
Yeah, there's been a few APK captures, which means they got it from somewhere. So it's not on any of my devices yet, but I'm always the last to get all that stuff anyway. Oh dear.
If you were to download the latest Android source, which I've only done once, and I didn't do a lot with it, would you find potentially the answers to what you were just talking about?
The Play Services stuff?
Yeah.
No, because it turns out all of that functionality is not in AOSP. It's a separate bundle of code that's maintained outside that tree as closed source. So downloading AOSP would give you some insight into how the Bluetooth services are working, but all of this stuff is completely outside that scope. Good question though. Now you didn't hear this from me, you could pull it off of a device and reverse engineer it. I can't say I've not tried that or anything, but you could do that. It turns out it's not really easy to do anyway, but yeah, exactly. So, okay. Now there is actually a third type of Eddystone packet format that I didn't mention before. And the reason that it didn't fit over in the previous slide is because it's not an identifying packet. This is not a way for a beacon to tell you what it represents, what kind of resource it is, whether it's a UID or a URL. This is a packet called the Eddystone TLM, which stands for telemetry data. So this packet is focused simply around the type of metrics that are on the actual beacon that you might want to present to the application. So it might be interesting to you if you're building, say, a management dashboard for your deployment of beacons or something like that, to figure out, well, what is the battery voltage on this beacon? What is the temperature? How long has it been since it last reset? How many advertisements has it sent? Those 4 pieces of data optionally can be sent by any Eddystone. They don't have to be. So you may not necessarily see this if you just go buy one off the shelf. But this data allows you to perform some more diagnostics or some metrics on what you have out in the field to say, well, is the battery low? Is it going to die? Did this thing reset when I didn't expect it to? Maybe also because of a low battery condition. And sort of do some management on the beacons you have out in the world. Now, realizing though that this is coming off the beacon, so it's a BLE advertisement out in the world. So you still have to be able to capture that somehow. It's not like these things are magically connected to the web all of a sudden, and they're being able to push that data up to a backend service. Or can they? So this in and of itself is not necessarily that interesting, but when you look at the next piece of the puzzle that Google introduced, which is their proximity beacon APIs, this starts to make a little bit more sense. So again, those beacons broadcasting that data when the only device that can necessarily pick it up are your users, by itself doesn't necessarily make a whole lot of sense. But what you start to see is this proximity beacon API adds some new features as a back-end service maintained by Google that you can include in your application to provide some additional features and functionality around your beacon deployment. Okay, so this is separated into a couple different pieces. The first is metadata, or what they're calling attachments. So remember I mentioned that one of the biggest issues with the beacon is the amount of data you have to stuff in there, right? 31 bytes is not a whole lot of data. So if you want to tell the user, of whoever's walking by this beacon, some more information, maybe you want to tell them the address or the location or some more key value information about this particular physical element that the beacon is attached to. It's very hard to cram all that in 31 bytes, especially when the whole bytes have been taken up by the standard format anyway. There's nothing left for you, okay? The beacon attachments are designed to solve that problem. Beacon attachments allow you to supply an additional 1K of data along with any given beacon. And that data is associated in their backend API. So the way that this basically works is when you are deploying your beacons out into the world, you declare that this beacon is at the front door of my store. And the front door of my store has all this additional data that I want the user application to have access to associated with it. And then through some back-end magic or some code that you write, when the user walks by the beacon, you can pull the API to get the additional data associated with it. Okay? So it allows you to get much more context pushed to the user than just what you can cram into 31 bytes. Okay? So that's kind of cool.
Can you also detect who the user is at that point?
Can the beacon detect? Well, I mean, to some degree, yeah, because they're making a web request.
Right.
So you could do some analytics on there as well. Definitely.
So is this going through Play services as well, or like where is this back end?
Right now, it's just a REST API. So, and this is live. This is a REST API. Go to developers.google.com/beacons, and it gives you all the REST API documentation. So you could write your own client to that web service and interact directly with the REST endpoints manually. There are no client-side APIs for this yet. Okay.
Why would you take that approach versus just broadcasting the URL and then in your own app hitting the URL and getting the data?
So you certainly could. The trick there would be that you might have to come up with a way to use the UID format with the instance field and find a way to encode the URL in that field. The difficulty with using Eddystone URLs for a private deployment like that is they will also get picked up by other things, and it won't necessarily be scoped just to your application. So the idea is if you really want it scoped to your app, it's best to stick to that format so that things like the physical web that we haven't talked about aren't picking up your stuff inadvertently because it's some private URL that's protected that no one else would have access to.
Has Google said whether they're going to charge for that API service? Is there like a quota?
As of now, there isn't.
Okay.
It's part of the Play API console, and like most of the Google APIs that are in that console, they do typically have quotas. I don't remember what it is for this API, a few 100,000 a second maybe. But if you go in and look at the API, it'll tell you what the quota is in your developer console. Definitely. Okay, the other piece of this is beacon provisioning. So take that use case that I just described before where I have a beacon, it's at the front door, and the front door has this metadata attachment of all this other data that the application needs to see. What happens if that beacon craps out, right? And maybe not just the battery dies, because that's easy enough to replace, but maybe one of the chips blows up. It's 200 degrees outside and the smoke gets let out of the chip and now we're screwed, so we have to replace it, okay? The difficulty if you have hard-coded into your client app which beacon means what is that that identifier just changed associated with the role that that beacon is playing. Okay? If you instead trust the backend beacon API to map what physical beacon means what beacon role, like this ID means front door, then you can basically be free of that problem in your client-side application. And the provisioning side of the API is what allows you to say, this new beacon is now the front door, decommission the old one. Okay? So it's starting to create some more things that you wouldn't necessarily put in your client-side software, but you could create a web dashboard or something of that matter to deactivate one beacon, reactivate a new one, and then go install it. Okay? And that then allows this concept of dealing with beacons and their attachments in terms of the names and roles they're given to continue to work flawlessly. And your client application doesn't have to care that you swapped out a bunch of beacons. Okay? So that functionality is in there as well. And then the last piece is diagnostics. So this is where that telemetry data comes in. So if you're using the beacons API, the idea is that your client, when it observes a beacon, that's what they call it, when it observes a beacon's identifier, the client is also responsible for observing if that beacon is sending telemetry data. And when it posts up to the API, perhaps to get the attachment data that it found a beacon, it sends them both. So it's kind of like crowdsourced metrics, right? Your clients walking around are actually giving you the telemetry off of your beacons. They just don't know it because your application is sending it along with the identifiers to get the back-end information. Okay, so that's all coming at once. And then on the API side, you can do things like setting alerts. So you can get a notification when the batteries are low on your beacon, or when the beacon reset unexpectedly because the counter went back to 0, or maybe the beacon moved. Right? The beacon doesn't actually have location data, but if the telemetry data is being passed up by a device that does, like your phone, then you could say, well, that location on that observed beacon is 200 miles from where I thought it was going to be. And you could set something on that. Maybe if your beacons are in zip cars, someone stole the car, right? Who knows? Something like that. So all of that stuff is packed into the new proximity beacon API that is a backend that all developers can use. Okay? Now again, it's all just a REST API right now. The theory is the nearby messaging API will wrap some of this functionality. So when you say, I want to observe these beacons, and Play Services comes back and says, here's your beacon, the idea is if there were attachments in that stuff, they would give it to you at the same time. So you don't have to go through all those steps if you're using Play Services. Again, I don't know how that's going to work out yet because I haven't seen the docs, but that's the plan. Okay? So another vote for Play Services. Yeah.
Do you think there will be hardware that will support Eddystone but also have other GPS and Wi-Fi chips and other?
I don't see why not.
Okay.
Yeah.
Are there any available right now?
Not that I know of. Yeah, I mean, there's nothing stopping anyone from implementing that firmware in a larger scale device of some kind. And in fact, when we get to the physical web, you'll see the Bluetooth is not the only way to create a beacon either. But I can't think of one off the top of my head that actually does that right now. Maybe the home automation guys have got one working. Yeah, right. Oops, sorry. Okay. Now, one of the really cool things about the Proximity Beacon API is that you have existing deployments. If your company, your application has already been using iBeacon, or if you've been using the AltBeacon standard, if you don't know what AltBeacon is, don't worry about it. It doesn't really exist anymore. But it was a thing for a while to try and combat Apple's iBeacon being Apple only. So the AltBeacon standard, iBeacon, and the new Eddystone, all of these beacon types can be registered with this API. It supports them all. Okay. Now Eddystone is the only one that has that telemetry component to it, so some of them won't necessarily be as smart as other beacons inside of the API, but if you have an existing deployment, you don't have to go rip them all out just to use some of these back-end features if you don't want to. Okay, it does support them. So that's kind of cool.
Does the Bluetooth scanner API support iBeacons as well? Is there a way to use it with that?
Well, so as I showed you in the example, the Bluetooth scanner API itself is not real opinionated about what it returns. If I don't set any of that filter stuff that I put in there, Beacon or the Bluetooth scanner is just going to give me every advertising device it finds. And that's going to be every BLE device that's advertising anything. So that would include iBeacon devices if they were around. And if I knew the iBeacon packet format, which Apple says I'm not supposed to know unless I'm in the program, then I could parse out those individual elements and I could do that. And a lot of people have done that, right? Like some of the early cross-platform iBeacons, like Eddystone and some of those others, were just reverse engineering the iBeacon format and sort of creating their own SDK around it that wasn't quite cheating, but was enough to work. So there's a lot of that going on, and it does work. Because the API just says, here's a Bluetooth LE advertisement, here's raw bytes, you do what you want with it. And then you have to write the rest of the
I
code.
think it is cheating. Isn't the Apple iBeacon license very restrictive?
Well, I mean, it's one of those things, like, were you licensed and you did something you weren't supposed to, or did you just happen to figure out what the format was, but you're not covered under Apple's license?
Okay, well,
right? So it's the idea that they reverse engineer what they need out of the packet, and they created an SDK around it. And that's basically how that company got started. So it's cheating, but they're not breaking any license agreements they had actually made. Right, exactly. So, tricky.
The broadcaster program?
Sorry, say that again?
How does the broadcaster configure the program?
Sure, well, it depends. It depends on who makes them. So, for instance, this one that I have is pretty much hard-coded. into what it can do. And when you buy these from the manufacturer, you tell them what you want each one to be burned in with. Some of them, like the developer kits that you can get from Radius or Beacon, they either come with an app that will connect to the device and reprogram it, or some of them actually have standard mechanisms of doing so. Now, the Eddystone does not have any standards for configuring UID, but there is a standard for configuring the URL, the one we haven't talked about yet. I don't really go into it, but if you go to the GitHub page where the standard spec is defined, they tell you how you can actually connect to the beacon and how to make it connectable. And most Eddystone beacons support that standard service because it's part of the standard.
It's essentially a static piece of data.
Right, but to some degree, it's really implementation dependent on where you get your beacons from. Good question. All right, so let's talk a little bit about the other format, the Eddystone URL. All right, so let's say that I have some URL that I want to broadcast to the world, and I want to stick that onto a beacon advertisement. Well, how do I do that? That's what the Eddystone URL format is intended to solve. And it may not sound like a problem yet until you hear about the physical web. So I'm jumping ahead of myself here, but the basic idea is I want to, instead of encoding some random set of bytes that only my application knows, I want to put a beacon out there that has a URL on it to my website. And anybody who walks by it will get a little notification saying, this is the website you can go visit for this thing, right? And we can kind of go on from there. But if I want to take this URL as an example, which is a URL to the Android page on our website, and I wanted to encode that into a beacon, the Eddystone format would take that and split it apart to look something more like this, okay? So what they do is some of the common bits of a URL, like the schema prefix and the domain suffix and all of those pieces that pretty much every URL has, those have been predefined in the format with known opcodes. And then everything else is just encoded in by character, right? So these are just the ASCII values of those individual characters in there. So things like the HTTP and the .com can be squeezed down so that we can, again, get as much as we possibly can into those 31 bytes. Right? That gets us somewhere, but we've all been around the web a long time, right? We've seen some of the URLs that Amazon generates and some of those other things, right? This isn't going to help. So inside of Eddystone URL, URL shorteners are very common occurrence, right? You know, this could get you so far, and it helps in some cases, but typically the common practice is if I have a URL that I want to encode into a beacon, I will put it through a shortener first, and then put the shortened URL in the beacon instead. Okay. Now, I chose the Google URL shortener for a reason, but I'm going to tell you why a little bit later. There is actually a good reason to use their URL shortener if you're using Eddystone beacons. We'll talk about it when we got to the physical web. Okay. Now, on the URL side, as a developer, it's not really my job to detect these things. Right? I mean, you could write a scanner to check the URLs and do all that if you wanted to, but typically the idea is that's going to be done by another component we're going to talk about later. If I want to participate in this in my app code, at most, I probably would just want to create my own advertiser, right? I want to turn my phone or my tablet into an Eddystone URL. I want it to broadcast the URL for my shop or something like that. Okay, I can do that using the advertising APIs that are also available in Lollipop and later. Okay, assuming you're on a device that supports advertising, because that is actually a hardware-specific feature, and not every device that has Lollipop can advertise. Right, like the Nexus 6, the Nexus 9 can, the Moto X cannot. You know, you kind of have to pick which device you're going to use in this particular case. So the code for something like this instead has to deal with the advertised side of the API. So we have the advertised settings and the advertised data. Those are the two pieces you have to construct to be able to advertise something from your Android device. The settings is kind of like on the scanning side. It's just about power and frequency. So you'll set up things like the advertising mode, which basically says how often am I transmitting. And they don't give you exact numbers. You just get constants like super fast, super slow, or balanced, that kind of thing. The transmit power, which again, you can't say exactly what the transmit power should be. It's just low, medium, high, min, max, I think are all the constants in there. And because this is a beacon, the two things you have to set is you have to say that this is not connectable, it's just a broadcaster, and this should never time out. Until I say stop, continue to advertise. The APIs allow you to say after 30 seconds, stop advertising or something like that. You don't want to do that. Typically, maybe you do, but in most cases you don't want to do that. So you set up the settings for your ad, and then you have to construct the ad data. The ad data is that 31 byte packet. What do I stick in here, right? Luckily, because Google used standard Bluetooth packet formats, I can use the Android APIs to construct that, right? I can say I need a service UUID blob and a service data blob, and I want those two things together in my ad. And then it constructs the byte array. If this were manufacturer-specific data, I'd be adding bytes manually into the packet that I send across. Okay? So a little bit more help from the APIs in being able to do that. Then, just like similar APIs we had before, we get access to the system's advertiser instead of the scanner, and we pass that settings and data off to the advertiser to start a new advertisement. Okay? And then my Android device will now start broadcasting this stuff off into the world. Now the other question becomes, how do I get that URL into that fancy encoded byte array? Okay? I could do it by hand. I wouldn't recommend it, but you can. If you read the standard, it's not terribly complex. You just have to write all the code. Or there's another way. As part of the previous iteration, which was UriBeacon, there is a code library available that can assist you in parsing the data formats. Now the UriBeacon format is not exactly the same as the Eddystone format. So you can't, there's not necessarily a one-to-one map here, but you can use the UriBeacon library to take that URI string that we have up here and encode it into the 16 or so bytes that need to go into the advertisement packet. Okay? That's all been done for you if you want to use it. Okay? Now technically this library is due to be deprecated, and there will probably be an Eddystone version of it that comes up later. But for now, this still works just fine. You can include this in your app and you can just pull it away. So you can pull that straight from Google's UriBeacon GitHub page. And I've got a link to that later. Question?
In the previous slide, did you set the broadcast enabled, or is there a default for that?
So it sets the, let me back up. It sets the advertising mode, which is what defines that interval. So you don't get to do it explicitly. You just get to pick fast, slow, or medium, basically. And it turns out that you can't even necessarily go and measure these things and expect them to be consistent, because they're actually implementation dependent. The OEM gets to choose what its transmit power levels are, and it gets to choose what its intervals are. So these would even be different from one device to the next. You could measure it if you were only targeting one device, which with an advertiser you might be. But don't expect it to be consistent across OEMs. Yes?
As these get more popular, is there a saturation threshold? Like if there were 10,000 beacons in this room, would my phone blow up? Would it even be able to detect them all? Or if there were 30,000 people in a stadium, you know, within close enough, within Bluetooth range of
Yeah. From a radio perspective, I'm not exactly sure what that point would be. My guess is that the software would crap out first. So it's probably dependent on how many unique Bluetooth addresses the Android framework can support. And that used to be a dangerously low number, like 32,000 or something like that. I don't know what it is anymore, or if they've changed it. So 10,000 beacons might still be okay. 100,000, I think you might actually start crashing the Bluetooth stack. Or at least that's what used to happen pre-Lollipop. So, but I think you'd hit that point before the actual spectrum started saturating, right, or anything like that. That's my guess anyway.
Okay.
Good question.
There's a Bluetooth standard that has the broadest range. What is it? I've seen it over 100 feet or something like that. What is it? How far from this thing?
Are you talking about just classic Bluetooth?
Yeah.
Yeah.
Whatever this is, I mean, whatever you're using.
Yeah, so I mean, this is Bluetooth low energy. This is all happening over Bluetooth low energy, which is intended to be a lower power, which typically means less range, transmission standard of the classic Bluetooth spec, which is, I think it's rated at 100 feet, but it's usually much longer than that. I mean, that's all governed by how high you turn up the radio, sure, basically.
So how close can you normally get to one of these things and use it?
How close?
Yeah, what's the range?
I can sit right on top of it. Yeah. You mean how far away?
Yeah, I mean, see how far away.
Oh, sure, sure. So these guys, which are transmitting at a fairly low power, I probably would lose it at about 50 feet, the way it's currently set. So the idea behind creating your own beacon deployment is typically you would work with the manufacturer, or some of the manufacturers like the guys over at Radius allow you to actually configure the transmit power level of the beacon over using their app. The idea is that you would want to tune that up or down to where you want that detection threshold to be, so that you could set it up that I can only see this thing when I walk up to the table, or when I walk into the room, or maybe when I walk into the office. You know, I think that the power would support all of those three use cases, and then you could turn it down so that you're not seeing multiple beacons at the same time if you're trying to pick specific locations, that sort of thing. So that becomes part of actually deploying your beacons and some of the tweaking you have to do in your own environment.
So how's it compared with like NFC and RFID and stuff like that?
Well, so NFC is basically contact, few inches. NFC won't work even this far away. RFID is power driven as well. So depending on whether you have active tags or passive tags and the power going through the detection antenna, you know, RFID could work in the same range, or it could work this far away. You know, so it's definitely much closer range. NFC is spec'd to only work this close. So does that kind of answer the question? Okay, cool. Okay. So the nice thing about that library is it does most of the hard work for you. Now the URL, remember, was not the only thing in the packet. I still had to include the frame type and that transmit power value to complete what is a URL packet if I were to send my own from my app. Okay, so the rest of this example is just prepending those additional values inside. Now an interesting note here is that while I know the frame type, this is a bit deceiving that the UriBeacon library gives me the power level. It doesn't. That's actually just a guess. And it usually just picks an average value that's fairly close to 0. So I mean, it works pretty well. But unfortunately, the Android APIs don't tell us what the transmit power is that we're being used. Right? I just get to set low, medium, high, whatever. I could do my best to guess what it is and check it and insert that as a constant, but there's no API to say what is the actual dBm value of your transmit power, so I could stick it in here. So a drawback of doing it this way is that we kind of have to fake it or find another way to get that information and insert it into our app if it's specific to a device and we can do that testing or something like that, or come up with an average. Again, the transmit power only has use in ranging applications. And in most cases, ranging is really used for nothing more than determining which one are you closest to or furthest away so that it knows which one to sort at the top of the list. So it's not necessarily a big deal. But if you really need to know that transmit power you're trying to do ranging, doing it from inside your Android application probably isn't going to work so good unless you can measure that and scope it to a specific device. Okay, so just a side note. Okay, questions so far? All right, so on its face, because I can see it on most of your faces, Eddystone URL by itself probably doesn't make a whole lot of sense. Why in the heck would I want to broadcast just some random URL when the other format for my application probably works just fine? Well, that's where we start talking about the physical web. So can anybody tell me what's up on the screen right now? QR code, that's right. And in today's world, or at least in the world of the last 5 years, yeah, at least in the world of the last few years, what were these things used for?
Rails.
Right, they would stick them on everything, right? They'd be on a bus, or on an ad on the back of a bus, or a bus bench, or a movie poster, or something, something you get in the mail. And they were always intended, for the most part, to be a URL on their website or something like that that your device should go to for more information, right? And the beauty of them is that, technically speaking, you didn't need an app to interact with them. Like, the app you needed was the barcode scanner. You had to go find a barcode scanner, you did that once. But then you basically had to get your phone out like David just did, right? Try and get it lined up there and set it up. And if you're like me, you've tried to do it behind the bus while you're driving and stuff like that. And it never really caught on because all that effort was required on the user's part. The physical web at its simplest form is intended to basically be what the QR code probably should have been. Right? It's intended to replace that functionality. In fact, their catchphrase, if you will, for the physical web is walk up and use anything. Right? The idea is that instead of me having to take my phone out, fumble with the scanner and figure out how to take the picture and then visit the URL, that information is now pushed to me. Okay? So now it doesn't, on its face, it doesn't solve the app problem necessarily, because there's still got to be something on the device scanning. But we'll see there are some ways that that problem is being solved in different ways. The real important thing to realize with Eddystone URLs in the physical web is that these URLs that you were having to pull before by scanning with your camera are now being pushed to you. And the applications or the functionality on your device can bring that context to the forefront without you having to do pretty much anything. Now, you may have to pull your phone out to actually interact with it, but not to get that data in the first place. Okay, that's a big change. All right, so physical web, what does it look like? It looks something like this. Okay, it encompasses a number of different parts, and I'll kind of walk through each piece because they're pretty readable up there. So starting over on the right-hand side here, we have these different types of devices that are advertising URL data. Okay. We've already looked at the Eddystone URL in very grave detail, right? This is a Bluetooth device that is broadcasting these URLs into something of a physical web scanner client that can handle them. But the physical web specification actually defines several others as well. So you can generate physical web advertisers using MDNS, UPnP, and SSDP. Now, does anybody know what those three things have in common? What technology do they run over?
I don't even know what they are.
HTTP? TCP?
They all have 4 letters.
They all have 4 letters. So all of those technologies run over Wi-Fi. So MDNS is zero configuration networking. It's bonjour, right? It's ways of devices to discover themselves, over a Wi-Fi network. SSDP is basically the same thing. That's how your Chromecast finds your Android device, right? It's using these little frames transmitted over your local Wi-Fi. UPnP is basically the same thing. Right, so they're all standards that run over your Wi-Fi network that allow you to, again, feed this same data. So this is more used for the home automation type space, where you would want to walk into someone's home and be able to maybe automatically figure out how to use their stereo or something like that, right? And it doesn't have to be Bluetooth, because when you walk into the house, you're connected to your home Wi-Fi. Okay, so they support that functionality as well. It's the same basic data that just broadcasts URLs at the end of the day into something that's scanning for them. Okay, so then the next piece of this architecture is what we call the physical web client or the scanner. Right, so this is something that typically lives on the mobile device. So it'll be on your iOS device or your Android device, and currently, as a prototype, there are physical web applications in both app stores. So you can go to Google Play, you can go to the App Store, you download the physical web application, and you can play with this stuff, right? This is an app you're not supposed to write. The only interaction you're supposed to do with the URL side of things is generate the content being broadcast, right? The scanning part is left up to Google in this case. Okay, so this is an app you can download on your phone from the Google Play Store. So, again, as I said, at the moment it's not solving the app problem. I still had to go get an app at some point to manage and handle all these things. The advantage is, though, after I did that, my phone's in my pocket. Right? These things, you can kind of see the screenshots up there, but while I can scan for beacons in the foreground, the really powerful thing about using this technology is that when I'm not even using my phone or when I'm doing something else, this app is in the background scanning for these things, and when it finds a beacon, it'll pop up a notification. Right? So I have a couple of beacons here that were found when I was sitting in my office, and I could see a notification that I just pulled down and say, oh, there's a URL here, I could click on it and launch it. Right? Again, if you're using, because these are just typically notifications, if you're using something like Android Wear, then that also is getting pushed to your wrist. Right? So now I really didn't even have to take my phone out of my pocket, because I got a notification here saying I walked by something. And if I really care about it, then I could take my phone out and I could work with it. Right? But it's not just buzzing in my pocket and I still have to deal with it there. Okay? So this data is now being pushed to the user so that they can interact with it if they care. Okay? Now I mentioned that this doesn't necessarily solve the app problem. Now, far be it from me to ever try and predict what Google is going to do next. But I have heard rumors that this is going to end up somewhere in the lower levels of the system. I don't know exactly where. It might be in the Android OS. We might see this in the final release of Android M. It might be in Play Services somehow. Or we might even see it in something like Chrome. Personally, my money's on Chrome because it's cross-platform. Right? A lot of people use Chrome on iOS as well, and so they're getting this functionality just by virtue of the web browser you're using. On Android, Chrome is the de facto standard if you're using Google Android devices. Right? So if someone had asked me today, I wouldn't be surprised if you see this pop up in a release of Chrome. But I don't know that for sure. All I know for relatively certain is that they're working on it, but I don't know when or where it's going to show up. So eventually, the physical web will become a core part of what's in your pocket without having to do anything, having to download any apps. Okay, that is coming. Okay. All right. So that's the scanner. Then in its simplest form, that application on your phone could just take you to wherever those URLs are, right? It could just launch them in your favorite browser or whatever those links end up going to at the end of the day. There is an optional component inside of what they specify to be the physical web. And again, this is something where, since you're not typically the one implementing this, you're kind of just relying on the fact that Google will probably do something like this. There is a back end that they call the physical web service. This is an intermediary between the client app and the open web. And it does a couple of things for you that really just make things a little bit simpler and nicer. It does things like fetching the data from the URLs that it discovers. So you may have seen it in the screenshot that I showed you before, but the physical web application wasn't just popping up a raw URL. Right? It looked more like a search result. It was giving me the page title, a description, an icon, and all of that stuff. That's because it fetches that data from the backend service, and then the client can display it to really look more like it came out of Google search. Okay. All of that data is coming from this service. Those requests aren't happening directly on the client. There's a couple of reasons for that. One of them is resource constraint. You don't necessarily want someone's phone constantly hitting the web just because they walked by a UriBeacon, right, or something like that. But the other reason is security, right? You also don't want someone's phone hitting those websites every time it walks by a UriBeacon, because the website owner can track those requests, right? And you don't want everyone who happens to walk by, even though they didn't necessarily want to interact with the content, being tracked in that way, right? So the advantage of the physical web service is that it buffers the client from that. The client still has to talk to this back end, which is in this case owned by Google, to get the informational data, but all of those individual scrapings are happening on the back end and then just returned as a single payload to the mobile device. Okay, so there's a security reason and a performance reason as well. So it's one of those things they sort of created and then ended up solving a bunch of problems later at the same time. There's a feature in the prototype that I don't think is actually used, but would be allowed to be put in there, which is a way of filtering out URLs. So if the backend service discovered that there was a beacon deployment out there that ended up actually just broadcasting a bunch of URLs that were part of a phishing attack, in theory, you could just put all those URLs in the blacklist of the backend service and none of the clients would see them anymore. Right? So it allows you to filter and create some firewalls that sort of affects all the clients without having to try and manage that client side. Okay, so it does some of that as well. It also does redirect follows, which is very important for user experience, right? Even with shortened URLs, we know that at a minimum, that shortened URL is going to go to the server and then redirect to what the actual URL was. Right? But what if that URL redirects to another one and another one? And the difficulty that that may create is, from the user experience perspective, they may actually be jumping around several pages before they get to what they want. And if at the end of that road it was actually a deep link into a native app, they jump into Chrome for no reason just to jump back into the native app. Right? So it functions, but it's not the best experience. The physical web service is responsible for traversing from the URL the beacon had back to what the actual URL is that the user should invoke. Okay? And then, so that way when they just click on the URL, it goes to the web page or the deep link into the native app or whatever it was supposed to do in the first place. Okay? So it becomes a much better experience. Yes?
Does any of that data persist in the app, or is that optional to the app developer to maybe have broadcasts persist so that later on I can go check and see what I walked by?
In the current scanning prototype, I don't know of anything that they're doing along those lines. They may I wouldn't be the least bit surprised when this sort of becomes a formalized product in whatever it is, that there's some sort of a backend API that, you know, Beacon developers can get some sort of analytics or information, or things like, you know, scoping the crawling and that sort of thing. But as far as I know right now, none of that is in the system. Okay. Other questions on this? Okay. And then again, on the other side of this is the open web, right? Now, at its simplest form, this is interesting, but it's not necessarily, it's not as good of an experience as it could be, right? So we can broadcast all these URLs, and users can be going to mobile web pages all over the place, but most of us here are app developers, right? We don't like mobile web pages, we like native apps. That's why we do what we do. So is there a way that we can leverage this technology to get users into apps instead of out to the web? And the answer is of course. So using a series of technologies that are not new, they've existed for a very long time, at least on the Android side, we can leverage this functionality to get users into applications as the result of walking by one of these beacons instead of taking them out to a web page, right? So if you're an Android developer of any caliber, you've probably seen this exact same thing a million times, right? If this is new to you, let me just quickly walk through it. Basically, this is a filter that can be placed on any activity in your application, meaning any screen. And what that declares are certain types of actions that that activity can respond to, right? It may be something as explicit as show that screen, or it may be something as implicit, in this case, as here's a URL. Right? Now this example happens to be a URL that has a custom schema, but there's nothing saying that this couldn't also be an HTTP URL to my company's website. Right? So this could be http newcircle.com, some path, and when I, as a user, click on that link in my browser or in an email or anywhere else on the system, the power of Android Intents says that I can go straight to that activity as a deep link instead of going to the web page. But if I don't happen to have the app installed, then it'll load it as a URL in the browser, right? So there's that natural fallback in there. But if I have the application installed, and as an app developer, if I properly map the URL schemas between what I'm putting on the beacons and what's in my native app as deep links, then I can take existing users back into the app. So it's a great way to re-engage existing users of your apps, just because they happen to be interacting with something you own physically in the real world. Okay? And at the same time, the web URL portion of that, if they don't have the app, could be used to take them through a flow that gets them into the app. So you can even potentially get some more users. Whereas with the private deployment piece, that may get existing users engaged, but it's not going to get new users into your app in any way. Okay? So this helps you by sort of attracting new users through this functionality. Now, there's an additional piece in there that again is not new, that helps you with this as well, and that's app indexing. Has anybody heard of app indexing before? Okay, a handful of people. This is a Google technology. It's actually something they introduced last year, I think, and they've just sort of iterated on it since then. But the idea behind this is it's a way for you as a site owner to mark up the pages of your site, declaring places where content in your site matches up with content in your app. Right? So this is a snippet of something you would see on the web pages of your site. And what this markup is basically declaring is these are the URLs in my app as a deep link that match up with this same type of content. So maybe it's a product details page, and you have a product details page in your app that responds to the same information. So if the user has the app, you'd want them to go to this deep link, and if they don't, they can just go to the website. Okay, so the advantage of this is it allows you to use those HTTP URLs on your beacons, but then the app indexing piece will allow that to launch as one of these custom URL schemes in your app. Now this used to be more important than it is now because it was easier to do custom URLs than HTTP URLs on Android, and on iOS it was the only thing you could do. Right? You couldn't deep link into your iOS app using anything except a custom URL scheme. Now in iOS 9 that's changing, and eventually they are going to support HTTP URL deep links as well. So this may not be as important now or in the future. But the best part of this was being able to take a web link and convert it into two unique paths, one for iOS and one for Android. Okay, and you may still want to do that if the path structure is different, even if the root URL is the same. So this basically allows Google to crawl your site and make that mapping. You know, when I see this URL, this is what it means for the native app if they have it installed. Okay, this functionality was originally designed so that you could get app links in search results. If you did a Google search for some content, and the search result had a website, but you also had their app installed, they would put a link to the app in the search result. That's what this was designed for. But I mentioned before that there was something very important about using Google's URL shortener. Google's URL shortener parses app indexing markup as well. So if you shorten URLs that go to your indexed pages, the URL shortener will do the appropriate following of links so that when it launches on the iOS or the Android device, it launches the indexed link just like it would have from the search result. So you can create one URL for your beacon that goes to 2 different places in each of the native applications. Right? So it helps beef up your deep links instead of just hard coding them using the old way. Okay? All right, last thing. There is an additional feature that is still in beta that is called app invites. This is similar to app indexing, but what this is really responsible for is, let's say that instead of taking the user into your app or to your site, what you really wanted to do is say either you go into the app if you own it, or if you don't, go straight to Google Play or go straight to the App Store. The app indexing markup doesn't really support that very well, but you can do it with app invites. An app invite is just a way for you to generate a link that you would share with your friends that says, go download this app I'm using. And if they click on the link and they don't have the app, they go to the App Store. Right? If they do have the app, it's treated as another deep link that you can handle in your native application. Right? So if your only goal is use my app or download it, you can use app invites links. And if this works, you can do this, although they're probably going to iterate on this quite a bit because it's still in beta. If your goal is go to the web or go to the native app, depending on what you have, indexing pages is going to be the better way to generate those URLs. Okay? Make sense? All right. Questions about any of that?
Any real world instances of physical web stuff? Like Dunkin' Donuts or...
Not that I know of yet. I mean, really, until they just announced this stuff, UriBeacon was considered experimental. And the physical web, I think to some degree still is. They call it a prototype. So this is ground floor stuff, for sure. I mean, this is not something that we see a lot of people doing yet, but now that we have Eddystone, this is going to accelerate.
There are some NFC things, right? Like I've been in SFO before and there's a billboard and you put your phone up to it and you get like a book or an album for free.
Sure, sure. But I don't know that I've ever seen any of them using this technology.
Absolutely not. But to the user, they can't tell the difference.
Sure,
They
absolutely.
don't care what the-
Absolutely. Yeah, so I think what we're going to see is, hopefully, what I would like to see is all those disparate concepts that were doing something similar finally starting to standardize on one open thing. That's what I would like to see out of this. We'll see. People have different opinions, I'm sure, but okay.
NFC, you still have to take your phone out of your pocket.
Yeah.
And touch it. Yeah, you can't even be like, back here. Right. So here's a bunch of information. You don't have to write it all down, or make sure. Obviously, it's going to be on the video, and we'll make sure you have the slides and that sort of thing as well. But these are links to the GitHub pages for those projects. So the physical web project, the Eddystone project. The Eddystone project links to the old UriBeacon project. So if you want to use those old libraries, like I mentioned, you can do that by getting through that link path. I have some additional sample code that I wrote that's on my GitHub page if you want to look at that. And then if all the stuff that I showed you on those slides with Android code, if that made no sense to you, like you've never seen the Bluetooth LE APIs and the stuff I said was just like, I got no idea. I did about a year or so ago, I did 2 video tutorials on BLE and Android. One of them was focused on just the Lollipop update, and the other one was just how to use the BLE APIs in general. If you want to know more about that stuff, go watch those videos, and there's some sample code and stuff you can run through along with those. I've also got the 2 Google videos linked here that were paired up along with the release that just came out with the Beacon API and the Eddystone format and all of that. Okay. As far as beacon hardware, which we've already talked about a little bit, there's a ton of manufacturers. I think I can think of at least 10 that are making beacons, and most of them have Eddystone support already. These are my 3 favorite. So, I mean, if you ask me where should I go, this is probably where I would point you. KS Technologies, they're the guys who make this one that's in my hand here. They're actually local. They're in Colorado Springs. And they are amazing to work with, right? You know, they'll get you anything you need and they'll customize it for you. What I really like about their approach is it's simple. They don't try to generate 5 or 6 layers of SDK between me and the beacon, right? They let me use the standard APIs that are in Android and everything's just simpler, okay? So they're definitely my favorite. The one thing that can be a problem with these is they only make them in battery powered. So if you want a beacon deployment that is powered, plug into the wall or something like that, the other guys, this logo in the middle here is Radius Networks and then Beacon. Both of those guys make beacons that is basically USB powered. So it's just a little thing that you can plug into a wall that supports USB and you just plug it in and leave it. I've got 2 of those in the other room that are currently transmitting right now. Okay, so you can use those for that. Question?
And how long do the batteries last?
So in this particular implementation, this battery will last 10 years.
Oh.
This is a coin cell battery in here. So on the Eddystone firmware, this device lasts 10 years. When I reprogram it with the iBeacon firmware, it lasts 1 year. Just because of that transmit rate difference. So that obviously is going to vary depending on where you buy them. But at least for KST, that's their numbers.
How much do beacons cost?
This, in single piece quantities, are 20 bucks. But when you buy them in like pieces of 10 and stuff, they'll discount that down for you.
Okay.
A lot of the other, like Radius's dev kit is 40, I think, and you get 3 beacons in that. I forget what Beacon's pricing is. The other thing that I really, really like about Beacon specifically is that they have a back-end service, they call it Phi.net, that is intended to help you manage and sort of manage your distribution of physical web beacons. So we talk about the Proximity Beacon API and a web dashboard. That stuff's all new, but I can pretty much guarantee you that they'll provide you with a working web product that has those features in it soon. They already have a working product that was specific to the older version of physical web with UriBeacon, and they're retooling it to work with the newer Proximity Beacon APIs as well. So that's a product that the other guys don't do if you want sort of a ready-to-go out-of-the-box web dashboard to go along with all your beacons. Okay, so Beacon does that. Question?
I'm curious how you see this relating to specifically the physical web relating to Internet of Things and the Brillo OS. Do you see much overlap there?
On the surface, I'm going to say no. Primarily because these devices typically are very simple. You know, this device doesn't need to do anything more than have a packet to shout every second or every few seconds, right? So the controllers in these things they're not even microcontroller class. I mean, these are embedded stacks typically that have one job. Brillo is basically a stripped down version of Android. So it's designed to run on 32 64-bit class systems for much more powerful computation and processing. Now, I can't say that you wouldn't create an embedded IoT device using Brillo that has a beacon component, but I don't know that something like this ever needs to run Brillo, you know, or it's just a different class of system. So there may be some overlap in terms of features, because some of those devices that may be doing 100 other things also transmit a beacon frame. But the other way around, maybe not so much. That's kind of my thought on it anyway. Okay, yes?
Can you change, so there's 3 different message types for Eddystone. Can you change that message type while the beacon's still up and running? So like, can you do a URL and then a telemetry and UUID message?
Oh, absolutely. In fact, you almost have to. So take the telemetry example, right? I mentioned that a telemetry frame is not identifiable. There's nothing about that frame that has the ID information in it. So the recommended use case is if you're doing telemetry, you interleave it with one of the other types. So you have a beacon that transmits a UID and then a TLM, and then a UID and then a TLM, you know, or vice versa.
There's no spec on that interval. You kind of grab one message and wait around for the next one.
That's exactly right. So the sample application that I have on my GitHub that's an Eddystone scanner parses out the UID and the telemetry frames and pairs them together for each device. So you can kind of get an example of how that works. You basically use the device address as the common key between the two. But you're exactly right. You have to wait for one, then you wait for the other, and you match them up. Right? That's something that the Nearby Messages API claims that it's going to do for you. You know, because it's basically, it's doing all the discovery, you just tell it what kind of beacons you're interested in. So hopefully some of that will be masked, but if you're doing it yourself, you absolutely have to. Just as an example, for demonstration purposes, these beacons are transmitting all three, just in sequence. So it does a UID, a TLM, and then a URL packet, and it just cycles right through them as fast as it can.
Another question from the security side of the house. So you said the telemetry message, when you use it with the, I don't know if it was the physical web services, but you could broadcast information back to them about like what the power is of the beacon. They can use the GPS coordinates from your phone, so the beacon is not where it's supposed to be. You can spoof all that information, or is there any sort of security around the people hitting those endpoints?
Well, so the idea there would be that the yes, the endpoints are authenticated,
Okay.
so there is that. But the idea would be that typically that would be found in a private deployment, so it would be using Eddystone UID instead of just the physical web, where those things literally are being handed off to another application. So it would be your application for the beacons you own that's responsible for retrieving that data and pairing it up, or in some cases relying on Play services. But that whole loop is either handled by Google's code, but in any other instance, it's an OAuth authenticated API.
So you don't have to worry about third parties picking up your beacon and then saying it's somewhere else.
Or hitting your endpoint and spoofing the data, right? If the data is being spoofed, it's because your application is faking it, right? Now, that does mean that it's on you to not transmit user data, like their location, for improper purposes, right? But that's just typical app development stuff, right? You got the permission, now you're up to do with whatever you want with it.
Thanks.
Okay.
But couldn't somebody in a private deployment, couldn't somebody with an app on their phone spoofing a beacon that they're listening to?
I'm sorry, can you ask that question again?
Couldn't somebody with their phone spoof any beacon that they're listening to? Because they're collecting all the data, it's not encrypted. They could just rebroadcast that data from their phone from if they'd written an app to do that.
Yeah, I mean, in theory, that's true. So, I mean, the question is, what would they spoof? So, I mean, you're basically saying that you get the ID packet from a beacon, and then you retransmit it.
Yeah.
I mean, at best, you could modify the identifier to make it be something different, and then the scanning application, well, first of all, the scanning application is going to see the other one too, because there's no concept of directing an advertisement. So, I can't write an app that steals the advertisement and then broadcasts something different, like proxying. It's broadcast to everyone listening, so the scanner in range would see both.
Right.
So it would still see the original one and this modified packet that may be junk. And I mean, yeah, theoretically, a poorly coded application, maybe you get an instance ID out of range and you can cause it to crash or something like that. So there's some penetration testing you could do there, for hardening your application or something like that. But there's no personally identifiable information in there that I think would be worth spoofing necessarily. That would all come from the backend API that's not part of the beacon, right? It's pulled from the web service.
I'm thinking about gaming applications where somebody is trying to get points quicker.
Oh, sure. You might be able to come up with something like that, definitely. And that's something as an app developer scanning, you'd have to consider.
Yeah.
A question about the proximity beacon API. Is it basically an open repository where anyone can translate the ID into richer information, or will be specific to whoever owns the beacon? Or is there any authentication essentially for the REST API?
Yeah. So I think it's the authentication is, I don't know this for sure, but the authentication is basically going to provide scope so that the beacons that you register under your authenticated connection to the REST API are for your application.
Wow.
It's not like an open thing where I can go read the beacons from anybody else.
Or maybe the bus stop will have something that is registered openly so that anybody who's interested in writing a transit app can translate the beacon into a much richer set of data about what bus lines are on this thing.
Right. Yeah.
I'm not sure if that is the direction that it.
Yeah. The intention would be that those beacons are scoped to that bus line's application.
RTD, and I can't get it.
Right. If they wanted it to be more wide open than that, which might be too wide open for that use case, you could do something more physical web-like and encode them in URLs.
Essentially, it's a convenience service then, right? Because like, if it's going to be only pertaining to the owner of the beacon.
Right. I mean, it's essentially...
Google.
Yeah. It's essentially something that a lot of people were already doing,
Right.
and Google just said, we can kind of do this for you. So it's still something that's private to your company or application. It's just now there's a web service available for you to use, so you don't have to write the back end. Technically, you still have to write the front end, and I think their idea is that the front end integration with this API would be from a web application, not a mobile application, but you could do either one, right? I could write an Android app that I use to manage my beacon fleet, but the sample code that they give you is in Python and server Java. So I think the idea is that you would write a web application running on App Engine or something like that that is your dashboard for your beacons, and the mobile devices are just picking up the data.
Yeah, that's actually what we did. I worked at NCR. We rolled out beacons for Wendy's, and we had to write our own dashboard, and it was pretty cool. But yeah, it was cool technology. You could place an order in advance, and you walk into Wendy's, and it would fire your order to the kitchen right away as soon as you walked in. So
yeah,
it's fun stuff.
So unfortunately, I'm sorry I talked too much. I don't have time to show my demos, but if you want to play with my demos, I can show you afterwards. If you want to come up, we can play with them. And all the sample code that I was going to show you is on my GitHub. That was the link in the slides. So you can look at it there, download it, and play with it yourself. So thanks, guys. Thanks for listening.